Good evening. Somebody's asked me for help with a problem. This goes all the way back to transformations in Unit 1, specifically translations. And I think it's a really good problem for a Math 30-1 student to be able to solve. So I've decided to make a video of the solution of this particular problem. The problem says that you start off with a function f of x equals x squared, or y equals x squared. And it undergoes a horizontal translation and a vertical translation. And that means that the new function is going to have an equation of y equals x minus h quantity squared plus k. You're told the two x-intercepts of the new function are 1 and 7, and you're asked to determine the y-intercept of the new function. So in my mind, if I'm asked to determine the y-intercept of a function, then I need to know the function. So the problem now becomes, forget for a bit about finding the y-intercept, we need to determine h and k. If we can determine h and k, then we'll have the equation of the function, and then we can determine the y-intercept, which is the actual problem. So how are we going to do that? Well, we know that there's an x-intercept at 1, and that means that the ordered pair 1, 0 is a pair of numbers for x and y that make this equation true. That means that if I were to put 1 in for x, 0 will be the y-coordinate that results. By the way, an x-intercept is always on the x-axis, and the y-coordinate on the x-axis is 0. We're also told that 7 is an x-intercept, and that means 7, 0 must be a point on the graph of the function, for the same reason that 1, 0 would be a point. So let's see what happens when we put 1 in for x and 0 in for y. We get this equation. Now, you cannot rearrange this equation and get a value coming out of it for k because you don't know the value of h. Similarly, you can't rearrange this equation for h and expect to get a value coming out because you don't know the value of k. But if we put in the other ordered pair, 7 for x and 0 for y, now instead of having a single equation with two unknowns, you have two equations with two unknowns, and this happens to be referred to as a system of equations. Specifically, it's a quadratic system of equations that you learn how to solve in Math 20-1. But forgetting about the specifics of how to solve this system, I think when you're solving any equation or system of equations, you ought to simplify things first. So I'm going to simplify the red equation by taking 1 minus h and squaring it. That means I'm taking 1 minus h times 1 minus h. And when I do that, I get 1 minus 2h plus h squared. If you write down 1 minus h times 1 minus h and apply what we traditionally call FOIL to it, that's what you'll get. We also have plus k. What happens if we do it with the second equation? Well, I'm going to have to FOIL out 7 minus h times 7 minus h, which is what 7 minus h quantity squared is, and I'm going to get 49 minus 14h plus h squared. But we also have that plus k. Now, a beautiful thing about this system of equations is that the top equation has an h squared plus k, and the bottom equation has an h squared plus k. So I can eliminate those. This is called the method of elimination, by subtracting the equations. I'm going to take the top equation and subtract the bottom equation. So what do I get? Well, 1, I'll just highlight these temporarily for us, 1 minus the 49 gives you the negative 48. Negative 2h, there's a negative attached to that 2h, minus negative 14h will give you positive 12h. Of course, the h squared minus the h squared gives you nothing, and the k minus the k gives you nothing. So what you're left with is this equation here, 0 equals negative 48 plus 12h. Wow, that's like taking candy from a baby to solve. We can move the 48 to the other side by addition, divide both sides by 12, and now we're kind of halfway there. We now know the value of h. Now, how are you going to determine the value of k? Well, the same way you would determine the value of the other unknown in any system of equations. You'd use substitution. You'd pick an equation relating h and k. I'm going to pick the red equation, and then you would put 4 into this equation every place there's an h. That's going to give us 0 equals 1 minus 4 in brackets, quantity squared plus k. Well, 1 minus 4 is negative 3. When I square negative 3, I get 9. So I'm left with 0 equals 9 plus k. And now I know that k is negative 9. So we know the values of these parameters now. And that means we actually know the value of the equation. If I were to take this known equation for the resulting transformation of x squared, y equals x minus h, quantity squared plus k, and I use the h of 4 and the k of negative 9, I get this function. Y equals x minus 4, quantity squared minus 9. At this point, you can feel free to grab a graphing calculator, enter that in for y1, take a look at the graph of the function, and convince yourself that it will in fact have the x-intercepts that it's supposed to have, namely 1 and 7, and it will. Now, what was the question? The question was, what's the y-intercept? Well, a y-intercept is found by replacing x equals 0. Because a y-intercept is a point on the y-axis, the x-coordinate of every point on the y-axis is 0, so we're just changing the x to 0. And then what do we have? We have 0 minus 4, which is negative 4. When you square negative 4, you get 16. 16 minus 9 will give you 7. So this is the answer to the question. The key to solving this type of problem is recognizing that when you have a missing parameter, I'm going to go back here now. When you have a missing parameter, and in this case we have two missing parameters, h and k are called parameters, you have to use ordered pairs and substitution to find the value of the parameter. Very often in these types of Math 30 questions, you have only one missing parameter, so you only need the coordinates of one point. But in this particular example, as we've gone through, just a quick summary here, you have to use a point to find an equation, use a second point to find a second equation, solve that system of equations which we went through to find the two parameters, and then you can answer the question. Once again, all we did at this point was we put in those two parameters into the function, and we had the equation of the function, which allowed us to find the y-intercept. To the person that was wondering about this type of question, I hope that helps, and to everybody else, I hope you got something out of it. Take it easy.